Hello, and welcome back to the last little piece to lesson 2.7. In this lesson, we introduced spread or range or standard deviation. And standard deviation is the average distance each data point is from the mean. And so if the standard deviation is large, it means that our data is very spread out. But sometimes you want to compare an individual to the mean that aren't really apples to apples. So let's look at an example, and then I'd like you to go and answer that in the forum on Canvas. Let me share my screen. The question says, let's say two students, Amy is in algebra class and Betsy is in statistics class. Amy is very happy with her score of 70% on her exam, while Betsy is discouraged with her 80% on her exam in statistics. Why would Amy with a lower score be more encouraged than Betsy with a higher score? I'd like you to go and answer that question on Canvas in the forum and discuss. We can use a z-score, which is the number of standard deviations a value is away from the mean, to use as a comparison. So when you're answering this question on Canvas, I don't want you to answer it using the z-score. I want you to answer it in words. That's why you think that's true. So the z-score is calculated by taking your data value and subtracting the mean. And subtracting the mean, either the sample mean and then dividing by the sample standard deviation, or if you have population data, then you would subtract the population mean and divide by the population standard deviation. They're all the same calculation. It just depends on if you have sample data or population data. So let's look at two students, John and Allie, are from different high schools. They wanted to find out who had the highest GPA when compared to his school. Which student had the highest GPA when compared to his school? And John and Allie, you can see that their schools have calculated their GPAs differently. So we're going to calculate the z-score for both John and Allie because you can't compare them apples to apples. If you look at their raw GPA, it definitely looks like Ali has a much higher GPA than John. But we have to compare them compared to everybody else at their school and how their GPA is calculated here. So let's look at John's z-score. So we're going to take John's GPA 2.85, divide by the school average of 3, and subtract the school average of 3, and then divide by the school standard deviation. And then we're going to do the same for Ali. We're going to take his GPAs, subtract the average from his school, and divide by his school standard deviation. So go ahead and grab your calculators and we'll calculate these together. Okay, so 2.85 subtracting 3. Let's do this in pieces so you can see it's important that you have the top subtracted first and then divide. Otherwise, you'll get a very strange number. Okay, now had we said 2.85 and just done it in this order, 2.85 subtracting 3 divided by 0.7, we would have gotten 1.44. But that's because it divided this first, the 3 divided by 0.7. So you have to do 2.85 subtracting 3. So if you want to do it in one piece on your calculator, if you put the numerator in parentheses, it will do it with the correct order of operations. Okay, and so Ali, 77 subtracting 80 is a negative 3 divided by 10 is a negative 0.3. So because this is on a number line, a negative 0.21 and a negative 0.3, this one is actually the largest one, barely, right? It's barely. 0 would mean that they're actually at the school average, but they're not. So John is below the school average, but not by much. And Ollie's not by much below his school average either, but John is a little bit bigger. So John is higher compared to everyone else at his school for his GPA. So let's look at another one here. It says 2 swimmers, Angie and Beth, from different teams wanted to find out who had the fastest time for the 50-meter freestyle when compared to her team. Which swimmer had the fastest time when compared to her team? So let's look at Angie. Her Z-score is 26.2, subtracting the mean, divided by the standard deviation. So she is 1 1/4 standard deviations below the average in her team. And Beth has a Z-score. Her time is faster, but compared to her team, we'll see. So, although, let's just write this out in words. Although Beth it says, which swimmer had the fastest time when compared to her team? And when we talk about speed, right, we want a smaller number. So further, smaller away from the mean from her grade or her team would be better. So although Beth had a slower individual score time, right, compared to Angie, Beth is faster than her team by 2 standard deviations. And Beth, I'm sorry, and Angie, let's make sure we can see what I'm writing here. And Angie is only faster than her team by 1.25 standard deviations. Because the Z-score, the unit on a Z-score is always standard deviations. And so what's cool is if we were to use the normal curve that we created with the empirical rule, we only know exact standard deviations of 1, 2, 3 positive and 1, 2, 3 negative, but not every data point falls at exactly one of those standard deviations. For instance, Angie was 1 1/4 standard deviations below. And so a Z-score gets you a very accurate number of standard deviations that you are away from the mean. So that is all for the last part of 2.7. Catch me back for chapter 3. We're going to introduce probability.